Hi guys, this is Kamran Sadiq here, and today we will be discussing a topic related to numerical methods, that is numerical differentiation. We will be deriving a 2-point formula for numerical differentiation. Okay, we have 2 points given, that is x0 and x1, and we have the corresponding values of f of x0 and f of x1, and we are required to find the value of dash of x0. Okay, so since we are not provided either with the derivative of the function, or we are not provided with the derivative points at this corresponding point, so we cannot apply interpolation technique to find this value. So we got to use the numerical differentiation technique to approximate the value of this function. Okay, for a quick revision here, first we know by Lagrange polynomial method that for a function that is continuous on an interval a and b, there exists a polynomial p of x which is the representation of that function, which is actually pretty close to that function. So by Lagrange polynomial method we have this formula, which is p of x is equal to f of x0 into the value of Lagrange coefficient at 0 plus f of x1 into Lagrange coefficient value at 1. So by taking the derivative of this function, we get f of x0 into the derivative of Lagrange coefficient at 0 plus f of x1 into derivative of Lagrange coefficient at 1. So that means we have to find the values of the derivative of these Lagrange coefficients first in order to approximate p dash of x. So this is actually the formula for the Lagrange coefficient at 0, which is x minus x1 divided by x0 minus x1. By taking its derivative, first of all we're gonna separate these two terms, x over x2, x0 minus x1, and x1 divided by x0 minus x1. So what we're gonna get here at the end is 1 over x0 minus x1. Since this term is a constant, so taking its derivative with respect to x will get a 0. So we are remained with 1 over x0 minus x1. Similarly, by taking the derivative of Lagrange coefficient at 1, we get 1 over x1 minus x0. So yeah, putting these two values in equation 1, we get p dash of x is equal to f of x0 divided by x0 minus x1 plus f of x1 divided by x1 minus x0. Okay, so in order to convert this formula for a single point, what we're gonna do here, we'll approximate, or we'll assume that x1 here is equal to x0 plus h. So putting this equation in the value in this function, which is x0 minus x1, we get minus h, and for x1 minus x0 we get h here so according to this. So we are left with in this function we are left with a point, only a single point. We have actually removed x1 from this equation for our convenience. Now arranging this, we are left with this equation, that is p dash of x, which is equal to f dash of x is equal to f of x0 plus h minus f of x0 divided by h. So basically what we have achieved here, we have actually written this formula in terms of a single point x0. So if we are provided with the function and a single point x0, we will be able to actually approximate the value of the derivative of the function at this particular point x0. So yeah, this is it. This is our required formula. This is it for today. This is actually a 2-point formula for numerical differentiation. Thank you so much guys for attending today's lecture. Stay tuned for more.